Hi, your next challenge is called Return the Factorial. You are to create a function that takes an integer and returns the factorial of that integer. That is, the integer multiplied by all positive lower integers. This term may be new to you, factorial. It's a mathematical function that we'll look at in case this description wasn't entirely clear. So let's go. I just Googled some random page for it and look at the examples. They make it the most clear. If you ever see this exclamation mark used with a number, that's the symbol for factorial, by the way. So it looks a little weird when you first see it. But essentially what it expands into is the number itself, 4, and then you keep taking one less until you get down to 1. And then you do a product of all of those numbers. So 4 is 1 by 2 by 3 by 4 is 24. You can see the same process happening with 7. And so you can kind of see how as the input gets bigger, this thing really starts to explode as far as size goes. Do a few more higher values if you want to see that. Anyway, that's what factorial is. That's what you are going to do. If you think about this problem in a general case, it's a lot like other things we've done. I had a nice way that I was going to do it that kind of built off some techniques we used in recent videos, so I'm going to do that, but feel free to go about this in a way that comes to mind for you. So if you remember, very recently we were using this select statement, and don't recall if we were adding numbers or what it was, but anyway, we did that. And I briefly mentioned how they use this to get just a range of numbers from 1 to the value. So that would be this is a good opportunity. This is very useful for me. I'm going to use this. And enumerable is system length. We'll probably be using that. And so what I want to do is return enumerable range. Now I'm going for 1, right? Because the factorial problem went all the way down, consecutive integers all the way down to 1. And this is the same, right? If we reordered them to 1 by 2 by 3 by 4. So that's kind of what my version's like, but it's the same end result with multiplication or addition. Instead of 10 though, right, we want to use whatever input they pass in. So this represents that collection of numbers from that. So now the next thing we got to do is to multiply them all together. And if you remember in another video, we used this handy aggregate function for that, right? We were doing, I think that was the summation where we gave it a seed value to. We said 0, and then we put in a lambda function as our second argument. We had a total. I'm going to start writing this out for my case because when you do multiplication, you want to start with 1. Otherwise, if we multiply everything by 0, it'll 0 out. So I'm just going to take this opportunity to customize it for the current problem. And then I'll just refer to each value as anything. We can call it n. That's good. Good variable name for a number. And then what we're doing each time, right, we're taking that total and we're multiplying it. Remember, we've done divide equal plus equal. This is the same thing for multiplication. And times equal n. And yeah, so each time we're starting at 1, total starts at 1, and we're going to multiply n. So 1 times 1, 1 times 2, 1 times 3, 1 times 4, all the way up. And I think this will do the trick for us. Let's see. System length. Let's try that. Cool, yeah, it worked. So I thought that was kind of nice because we were able to sort of take these things that we saw recently and combine them to solve, what at the surface looks like a very different problem, but in essence is very similar enough where we were able to use the same technique, and we just swapped out a new lambda function to do something different that we wanted. And we started our accumulator at a value that was appropriate for this problem. So hopefully that's more reinforcement to how powerful this technique can be. Second, this video wouldn't be complete if we didn't do the recursive solution to this. This is a very famous problem that if you ever take any kind of course relating to computer science, you're almost 100% guaranteed to be asked to do this. And it's usually used when you're introduced to recursion. Recursion itself would warrant its own video, but we'll do enough to get by. It's essentially when the method calls itself. And maybe I'll write this out first and then sort of explain it. The key, though, is that you can imagine how this gets stuck in a loop. If this method keeps calling itself, where does it end, right? So you kind of need this case to where you can tell the problem to stop calling itself. Otherwise, it goes on for infinity and your program stalls out, and that's not good. So in our case, let's say if num is greater than 1, I'm going to go return num times factorial. Look, I'm using the same name. Num minus 1. Let's return 1. So I guess I kind of inverted the base case here, but it's the same effect. Oh, first, before we do this, let's get a fresh screen here so I can run it and prove that it works. And then if you Google the term recursion, you'll find plenty of reading about it. To my point, as soon as they introduce you to it, look at this, they already implement the factorial function. That's how tied it is when you start studying recursion. But there's a little spoiler alert for you. So we'll go, we got the fresh palette there. You saw mine was inverted. I said if number was over 1, then we're making the recursive call. If not, just return 1. Same difference, So we'll run that. I don't need any kind of using statement. We're not bringing in anything here. Everything needed is right here. Isn't that kind of cool? That works too. The function is calling itself. You're used to functions calling other functions, the program executing, calling a bunch of functions. And so, yeah, this is a very powerful technique. When you first see it, it's a little difficult to envision how it runs. You kind of have to think about it or even write it out on a piece of paper, so you can imagine when the number, say, is 5 coming in, 5 is going to be greater than 1. So you're going to take 5 times factorial of num minus 1, which is 4. So you got 5 times factorial 4, right? And then this num, this 5 here, is sort of, we'll get into it, but it's sort of saved out for the next call. The next call runs with 4. That is greater than 1. So then you get 4 times factorial of 3. Then you come in here with 3, and 3 is greater than 1. So you get 3 times factorial 2, yada yada, 2 times factorial 1. Finally, when you get into 1, you see that num is not greater than 1, and so you simply return 1. And then you kind of picture these numbers stacked on top of each other, right? We had the 5, then the 4, then the 3 times some result, then the 2 times some result. And then finally, there's no kind of wishy-washy response. There's a hard answer. There's a, hey, 1, you know what I mean? That terminates it. Then it's like, okay, I have all of the values. There's nothing left to determine. Now operate on them, and it sort of unwinds, and then you get the 1 times the 2 times the 3 times the 4 times the 5. So I'm sure there's plenty of online diagrams that illustrate what I said there, but as usual, I'm more than happy to help. If you have questions, I can probably direct you to some of those resources or explain more. But yeah, key takeaway, be aware recursion's a thing. It's a very powerful tool, and it's definitely worth the trouble of learning and understanding. So I hope you enjoyed this video. Thanks for watching.